A 10-gram ball bearing is dropped into a 1 meter tall beaker of water. A second identical ball bearing is dropped into an identical but empty beaker. The first ball bearing takes 10% longer to reach the bottom. What was the drag force? Yes? Okay, which number is this for? So you have, I'll split this down the middle. Down the middle. So in this one here, you have some water, and the ball is dropped in it, and it goes down to the bottom, splash. And then in this one here, it's empty, and it just falls down. So this one's the easy one. Let's do this one first. U-V-A-T-S. I'm going to say down is negative, okay? U, 0, V, we don't know, A, minus 9.81, T, we don't know, S is 1. I said this is 1 meter.
0.01, right? Yeah, that's math, right?
I'll give you the mass too, which is good. What did I say the mass is?
0.01.
Okay. So here, let's get the time. What formula should I use? I think S equals maybe? Is that right? Yeah. So, now look at the mistake I made. Here should be minus. S equals U T plus a half A T squared. So I get here the time is 0.4515 seconds. Now here I say it takes 10% longer. So how can I make this one 10% bigger? What's a quick way to make it 10% bigger? Does anybody know?
The percentage.
Well, you could work out the percentage, but what's a quick way to make a number 10% bigger?
Divide 10 plus 10.
Yeah, to say, no, that's a quick way. So we multiply 1.1 is a quick way, yes. So here the time is 0.4967 seconds. The S is still 1, the A we don't know, the U is still 0. Let's get the A. V squared equals U squared plus 2AS.
Is T multiply
1.1. Yep.
1.1?
Yep. Here I take this T and multiply it by 1.1 because I want to make it 10% bigger, because I said here it takes 10% longer.
5.1. Okay.
You sure? Okay. Here.
What?
Plus what?
1.1?
Multiply 1.1.
Oh.
Are you sure? No, actually I don't want this formula, sorry. I want, because I don't know the V. What formula could I use? S again?
Yeah, you can use the S one.
Like S again? Okay. So S equals UT plus a half a T squared. So I get my A. So I get A is minus 8.107 meters per second squared. So the A is not as big, right?
You times the answer with 1.1, right?
Which
You
answer?
don't have to do that because we already know. Never mind.
Are you asking me?
Never mind.
No,
I
okay.
answered one answer too.
Can I continue?
Yeah.
So the acceleration is not 9.81 because there's a drag force going up. Yeah? So what force is going down? The weight. And what force is going up?
Drag.
The drag. Yeah. But again, I'll divide it by 2 because the reason is at the top, what's the drag? 0. And at the bottom, what's the drag?
The highest.
The highest value it'll be. So during its journey, we can say that the drag is approximately drag divided by 2. It would be wrong to use this number because it only reaches this drag at the bottom. And it would be wrong to use this number because then there's no drag. So we must use something in the middle. So this is a good, in fact it's a very good approximation, you might be surprised to know. Okay, the weight is mg, which is 0.01, was it?
Yeah.
Which is 0.0981 newtons. So you can say F equals ma, so minus 0. Drag over 2 minus 0.0981 equals ma equals 0.01a. Do we know the a though?
Yes.
Yeah, we do. What did I say the a was? 8.107. So the total, just remember that the total force is drag over 2 minus the weight. That this one and this one, they should oppose each other. Okay, so let's get our drag here. So I got here the answer that the drag force is on average 0.358 newtons. That's the answer. Yeah. So what I mean by that is at the beginning the drag is 0 newtons. At the end the drag is its maximum. In fact, I don't even know what it is,
We can
but it'll be, it's probably twice this number. Well, it should be twice this number. So at the end the drag force is 0.717 newtons, but in the middle the drag is roughly 0.358 newtons. At the start it will be less than this number, and then at the end it will be more than this number. But roughly it will be this number. Drag. Would you like a break?
Yes.
I thought so. So you can take a break for a few minutes, and then we'll do one lesson, and then
Bye-bye.
next time I'll need to try and do 2 topics, okay? But the projectiles was a big topic. I think if you remember last time I did it, I think it took 4 hours.
Don't forget.
Yes. But this time it only took 3 hours, which is good. Okay.